Hello guys, welcome to the YouTube channel of Spark Scholar. In this channel, we will be solving the problems in physics books. First, the book we are starting with is Fundamental of Physics of Halliday and Resnik. This book that we are going to use is the 10th edition, and the first. Let's take a look at a problem. Now, in the sample problem 2.01, we have you drive a beat up truck along a straight road for 8.4 km per hour, at which point the truck runs out of gasoline and stops. Over the next 30 minutes, you walk 2 kilometers further along the road to gasoline station. What is your overall displacement from the beginning of your drive to the station? Now, first they have asked us to calculate the total displacement, uh, which means that we need to calculate the total distance from the starting point of our journey to the end to the station. We need to calculate the total distance now, since we know that the truck has traveled on a straight road for 8.4 kilometers, and the velocity with it travels is 70 kilometers per hour. Now, after that, the truck runs out of gasoline. Then we walk for you almost walk for 30 minutes, and that is time, and that the distance you've traveled is 2 kilometers. Now, from here, we need to calculate the total distance. Now, the distance for we can the distance will be del x is equal to x2 minus x1. Now, initially, first you have traveled 8.4 kilometers uh, uh, from the to the point where your truck has run out of gasoline. Then additional 2 kilometers, which is will be our walking distance to reach the station. Now, when we add up the distance and we subtract the initial distance, that is 0 kilometer, since we started from zero, so our total displacement will be equal to 8.4 kilometers. Now, in the second part, what is the time interval del t from the beginning of your drive to the arrival at the station? Now, to calculate the average distance or the uh, average drive, uh, mm, uh, the time interval del t from the beginning to this station, we need to calculate the first velocity. Since Now, first we know that since the velocity, which is average velocity, and the dr represents the drive time, driving speed. So del x dr over del t dr. Now we will from here we will make del t subject and calculate the time that took us to travel the 8.4 kilometers. So we will divide the distance 8.4 divided by 70, which was our initial speed. So which was our initial driving speed. So from there we will get our time, and it is in hour. So we get our driving time, which is equal to 0.12 hour. Now, after driving, that when the truck runs out of gasoline, what we do is that we walk for 2 kilometers. So to calculate that distance, here as you can see that I have done it in the total formula. Del t will be equal to del t of driving plus del t of walk. So since we know that driving time is 0.12 hour, so to calculate the uh, time of walk time, then we will you be using the formula again. The distance sorry From here again we will use the t. So 30 minutes divided by 60, so we know that we've traveled for how much time. We traveled for 30 minutes, and we will be converting that minutes to the 60. Initially, since we know that walk time is 30, so we will dividing it by 60 minutes per hour to convert in the same units for other time. So from here we will get zero point 0.5, and when we add up, so the total time we get is 0.62 hours. Now in part C, what is our average velocity from the beginning of the drive to the station? Find it both numerically and graphically. So here we've not, I think I've not put the picture of the graphical representation, but here we will discuss the it numerically. So V average is equal to del x by del t. Since we know that speed is equal to distance per unit time, so V average will be equal to change over displacement over change over time. So total displacement we know is 10.4 kilometer, and the total time, since we've calculated in part B, so we'll put it here 0.62. So V average from we will get as equal to 16.8 kilometers per hour, which is approximately 617 kilometer per hour. Now in part D, they say suppose that to pump the gasoline you pay for it, and that to pump the gasoline, pay for it, and walk back to the truck takes you another 45 minutes. What is your average speed from the beginning of your drive to the return to your return to the truck with gasoline? Now we need to calculate the average speed of our initial uh, from initial to our final point. Now initially, first we will calculate the total time. So the total time will be sum of time which we took for driving, then walking of 2 kilometers, then again walking back to the truck, which took us 45 minutes. Now we will sum up these three times. Now, since we have calculated the driving time, that is 0.12 hour, then us adding 0.5 hour of walking to the gasoline station. Now since they told us that the walking from the distance, the time taking, the time we took to back walk from the gasoline station to the uh, truck was 45 minutes, so we will convert that 45 minute into the unit of hour. So 45 by 60 we get 0.72 hour. So we add up these times, and the total time we get is equal to 1.37 hour. Now to calculate the average speed, we need total distance over total time. Sorry, I forgot to mention total distance here. So you can write the total distance above, and in numerator you could write total time. So the total time will be 8.5 of driving, then 2 plus 2 4 to reach plus 2 kilometer to reach the gasoline station, and uh, walking back from gasoline station to the truck, it was another 2 kilometers. So in 10.4 we added 2 kilometer, that is our total distance. Now that adds up to 12.4, and the time total time is 1.37 hour. Now from here we will get our average speed, that is 9.01 kilometer per hour. This is the average speed of our journey. Now moving onwards to the sample problem 2.02. In this figure 26a is an X plot for an elevator cab that is initially stationary and then moves upward, which we take to be positive direction of X and then stops. Plot Vt. Now to plot V, initially this the first graph with blue line is our figures 26a. As you can see that initially a part, there is no it moves with the there there is no movement. So as we as the time increases, the position, the distance changes, and it increases up to B, and for at B it travels a lot of distance and reaches point C, and from there it again stops moving. Now when we look at the graph, we can see that here at point A, since first we point A, when we will convert this it into velocity. Since there is no distance traveled, as you can see, the value of position is 0, and 0 by time will be again equal to 0. So in our velocity graph, there will be no velocity. Our velocity will be 0. Now for part A to B, what we did is that we can see that our curve is increasing, so it means that the values are changing. So, and when we do the initial to final value, since for example velocity is distance per unit time, or velocity is rate of change of displacement per time. So what we will do is that we will 5 minus 0 divided by the difference 3 minus 2, and from there, this is not like accurate distance, but this is an approximate distance from which we will be calculating. So we will get our velocity. Here we got a value of 4. Then again, since we will do this from B to C, we will again use initial and final value of position and time, and from there we will get that it at this point, the car or whatever we have is let's the elevator cab will be moving at constant speed. At from part A to B, our elevator cab, its speed is increasing. Then at this point, it again moves with the constant velocity, and from there, from C to B, we can see that it is going to stop. So it is decreasing. First, the velocity is decreasing. Again, you can take two different values of time, and from C to this point, and we can see that our velocity is decreasing, so it will stop it after some time. Now at point D, the elevator cab will stop and become and will be at rest. Now let's take a look at example 2.03. In this, a particle position on the x-axis of figure 2.1 is given by, we have the equation of position, that is x is equal to 4 minus 227t plus t cube, with x in meters and t in seconds. They've told us the units of our display position and time. Now, because position x depends on time, the particle must be moving. First, the particle velocity, find the particle's velocity function and acceleration function. Now we need to find v of t and a of t. So since we know that we have position, so velocity is rate of change of displacement. So will be equal to dx by dt. So we will be writing d over dt, and at point x we will substitute it x equation. Now we will take its derivative. Since 4 is constant, it will be 0, and when for minus 27 t, t has power 1, we will power will be written next to 27, and we will subtract 1 from the power of t. So t power 1 minus 1, which will be equal to t0, and something with power of 0 is equal to 1. So plus t cube, we will do it again. So, we will bring down the 3 and subtract 1 from 3, and with this, from there we get v is equal to minus 27 plus 3t square. Similarly, we will be calculating the acceleration equation. So the acceleration is equal to rate of change of velocity. Now we have calculated the equation of velocity. We will be using that equation, and now again sub we will do is that we will take the derivative, and from there we will get our acceleration, which will be equal to 60. Now in part B, they say is there ever a time when velocity is 0? Uh, so we need to in this part we need to calculate the value of time at which the velocity of our particle will be equal to 0. So we will put v is equal to 0 in the formula or in the equation of the velocity. So from there we will make t subject. So our v will be equal to 0, minus 27 will remain as it is, and same is the case for 3t square. Now we will bring 27 on the other side. In side it will become plus 27, and 3 and 27 cancel out, and we get t square is equal to 9. So we will be taking square root on both sides. Square and square root will cancel each other. From there we get t, and square root of 9 is equal to plus minus 3. Since we know that t time can never be negative, so the time at which our velocity will be equal to 0 is at 3 seconds. Now, describe the particle's motion for t greater than 0. Now, for time greater than 0, we need to we have to explain the motion of our particle. Initially, we will put the time is equal to 0 in our displacement equation. From there, we can calculate that we get our displacement or position of is that our particle has moved 4 meters. After that, we will calculate velocity. Again, putting t equals to 0, we get that the speed of our particle is minus 27 meters per second, and acceleration will be 0. Now, the particle is moving in negative direction of the x-axis. Since the acceleration of our particle moves with constant, the acceleration of the particle is 0 because it moves with constant velocity. Now, for time 0 to 3, uh, for time 0 to 3, the particle has negative velocity. It continues to move in the negative direction, but acceleration is not 0, and it is increasing and positive. The sign of velocity and acceleration are opposite, which means that our particle will be slowing down. Now for the t is equal to 3 seconds. For the t is equal to 3 seconds, we need to substitute x is equal to x uh, value of time, that is 3 seconds, in our position equation. So from there we can calculate that x is equal to minus 50 meters. Velocity at this point is 0, and the acceleration with which it moves is 18 meters per second. The acceleration in this case is positive. Now for the time t greater than 3 seconds, the particle starts to move towards the right side of the axis. The acceleration remains positive but increases in magnitude. Same is the case for velocity.